The sinking of the Titanic stands as one of the most examined tragedies in maritime history. For decades, survivor accounts have described the ship's rising at a steep angle before it finally broke apart and vanished beneath the ocean. But one question continues to spark debate. Just how high did the ship actually rise? In this video, we'll take a closer look at the angles of the Titanic during her final moments. We'll explore how researchers arrived at their conclusion, the evidence that supports them, and the methods used to piece together one of the most haunting moments in maritime history. To determine the angles of the Titanic during its sinking, one of the best methods is through simulation. Recreating the events allows us to visualize how the ship behaved as it sank and even as it broke apart and went under. However, due to practical and budget limitations, our study takes a qualitative approach instead, meaning focusing solely on survivor accounts. Using these survivor testimonies as our main source, we estimate the ship's angle and recreate them using Blender, a 3D animation software. This program lets us simulate the Titanic sinking in real time, based on eyewitness observations. Our results are then cross-checked with modern studies and existing simulations to ensure accuracy. The process begins with identifying key moments, specific events survivors describe, such as the level of the water on the inside comparable to that of the outside, the submersion of the decks, and etc. These moments are animated through keyframes, gradually forming a timeline of the disaster. As the pieces come together, we create a clear, evidence-based picture of the Titanic's final moments, allowing us to see the tragedy unfold with new clarity and perspective. This video will be divided into two parts. In this first section, we focus on identifying the head trims of the Titanic during her sinking. Head trim refers to how much a ship is tilted forward or aft. That is, whether the vessel is dipping by the bow or by the stern. This is different from list, which measures how much a ship rolls from port to starboard. We'll explore lists later in a separate segment. As mentioned earlier, our reconstruction relies on identifying key moments in the sinking. Through extensive analysis, our research has identified at least 12 major key moments related to the ship's head trim. The first being the baseline or quote-unquote zero trim, representing the ship's condition prior to the collision, with no list or forward inclination. The final key moment corresponds to the break-up angle, which marks the maximum tilt the ship reached before structural failure occurred. Since this study focuses on angles prior to the breakup, we'll stop our analysis at that point. Before building our timeline, we must first determine the pivot point, the area around which the ship rotated as it sank. This point represents the vessel's center of gravity and acts much like the middle of a seesaw, where rotation occurs around a balanced axis. In the case of the Titanic, evidence suggests that the pivot point was located near or below the deckings of the fourth funnel, roughly corresponding to the ship's 584-foot forward point. This finding is supported by survivor accounts, even from those in Lifeboat 13, who reported that the area containing the condenser pump remained visible above the water, even late into the sinking. Studies by maritime historian Samuel Halpern further confirmed this observation, reinforcing that the apparent center of flotation or pivot area lay near this section of the ship's midline. With the pivot point established, we begin at a 0-degree trim, the moment immediately before impact. From here, survivor testimonies provide key evidence that help us track how the Titanic gradually began to dip forward. At about around 11:55 to 12:10 a.m., post-collision with the iceberg, survivors such as Johnson, Wheat, and Robinson observed flooding in the baggage room and G deck, visible from F deck near hold 3. Wheat reported that water began entering G deck roughly 10 to 15 minutes after the collision, right about by 12:15 a.m. Other witnesses described water rising within 6 steps of E deck, around 4 feet below it, shortly after Captain Smith and Thomas Andrews inspected the mailroom. At this early stage, simulations and comparative studies suggest the ship's head trim had increased modestly to about 0.5 to 1 degree, signaling the earliest sign of the bow's descent. By about 12:25 a.m., witness Poindexter reported water 3 feet deep on E deck within the crew's quarters. Approximately 45 minutes after impact, the ship's trim at this time was estimated at 2.5 degrees, indicating a slow but steady forward dip. This estimate aligns with hydrodynamic simulations by researchers such as Hackett, Bedford, and GHS, which show a consistent progression in flooding between the forward compartments. At around 12:45 to 12:50 a.m., Survivor Wheat described water flowing down the first-class grand staircase from E deck to F deck, just aft of the watertight bulkhead F. By this point, the Titanic's trim had increased to roughly 3 to 3.5 degrees as per our simulations and our best estimates, showing a more noticeable forward tilt as the flooding advanced deeper into the ship's interior. The next key moment, occurring around 1:05 and 1:10 a.m., was observed by Ray, who reported that water had reached E deck near the second funnel casing at the first class staircase. This trim was around 3.7 degrees, a sign of continued gradual submersion as flooding spread through the midsection. By 1:20 a.m., witness Dylan, Scott, and Threlfall reported that Boiler Room 4 was flooding rapidly, forcing engine room personnel to evacuate. The head trim at this time was between 3.8 and 4 degrees, suggesting severe but steady forward submersion. And then right about 1:45 a.m., accounts from Barrett and Nichols aboard lifeboats 13 and 15 described contrasting views. The forecastle head was not yet fully underwater, while the ship's stern propellers were visibly rising out of the sea. This stage marked a 4.5 to 5 degree trim, and as observed, it seems that the sinking has somewhat slowed down, basing on how slight there was in the changes of the angle, representing a temporary equilibrium phase in which flooding rates and internal water displacement balance, briefly slowing the ship's descent. Right about by 1:50 to 2 a.m., Phillips noted that the well deck was completely awash, with the ship now showing a slight list to port. The head trim was estimated at 5 to 5.25 degrees, marking a transition from equilibrium to rapid decline. At 2:05 a.m., Rowe from Boat C observed that the well deck was fully submerged. The ship's trim had now reached approximately 6 to 6.5 degrees, showing a marked forward incline as the bow sank deeper beneath the waves. Between 2:10 and 2:15 a.m., Lightoller reported that the water had risen up to the crow's nest and was sweeping across the forebridge, moments before he jumped into the sea. The Titanic's head trim at this stage was between 8.5 and 9 degrees, an extreme angle that left much of the bow completely underwater. Finally, at 2:17 a.m., based on our prior analysis combining both qualitative testimonies and quantitative modeling, the Titanic reached its breakup angle, estimated at around 26 degrees. This was the point of maximum forward inclination, where the stresses on the hull exceeded structural limits and the ship's midsection began to fail. Some survivor accounts suggest that the angle appeared steep enough for people to lose their footing or slide along the decks, supporting an estimated range between 25 and 30 degrees. After extensive comparison between testimonies and mechanical stress models, researchers have determined 26 degrees as the most credible estimate for Titanic's angle of failure. For the time intervals not directly documented, Blender automatically fills in the gaps between keyframes. The software interpolates the motion, creating a smooth transition that estimates the ship's angle in the moments between recorded events. This gives us a continuous and realistic visualization of the Titanic's changing trim throughout the sinking. The angles we've established so far are not yet final. To make our dataset reliable, we run each value through a simple triangulation process. Since our quantitative data gives us two results, we first average those by adding them together and dividing by 2. For example, our dataset for the quantitative data, both being 1.46 and 1.20. We add these together and divide that by 2, which would equate to 1.33. Once we have that quantitative mean, we combine it with a qualitative estimate using the same method. That being 1.17 then becomes the finalized angle for that interval. This quick divide and average sequence is repeated at every 10-minute point, allowing us to build a consistent, evidence-based timeline of the Titanic's changing trim as it sank. And that concludes the first part of our study, an in-depth look at the Titanic's head trim as she made her slow and tragic descent into the Atlantic. Through survivor accounts, technical data, and simulation-based analysis, we've traced the gradual forward tilt of the ship from the first signs of flooding to the final, devastating angle that marked her breakup. But our exploration doesn't end here. In the second part of this 2-episode miniseries, we'll shift our focus from the Titanic's forward incline to another crucial aspect of her sinking: the list, or how much the ship rolled from the side to side as the disaster unfolded. Using the same qualitative and evidence-based approach, we'll examine survivor testimonies, simulation data, and modern analysis to understand how and why the ship leaned to port and starboard in those final hours. Join us in the next episode as we continue to piece together the final moments of the Titanic, uncovering how even the smallest shifts in balance shaped the outcome of one of history's greatest maritime tragedies. See you in the next video.